Welcome students. So let's continue with the chemical properties of carboxylic acid. In the previous classes we have studied about the preparation of carboxylic acid and also the physical properties of carboxylic acid. In this part we are going to continue with the chemical properties of carboxylic acid. So in the chemical properties of carboxylic acid we are going to first see the reactions, that is reaction of carboxylic acid with the metals. Okay, we are going to see the reaction of carboxylic acid with metals. So here in this particular context, in this particular concept, first we are going to see the general reaction of the carboxylic acid's reaction with metals. So here generally the carboxylic acid reacts with active metals. Active metals means such as sodium, potassium, calcium, magnesium, zinc, etc. And they form their salt and the liberation of hydrogen takes place. Okay, so it is a very common reaction which you have studied in the 10th class also, that when acid reacts with metal, so it forms the salt, metal salt, and formation of and releasing of hydrogen gas takes place there. So here the general formula for this particular reaction will be RCOOH. It will be reacting with any of the metal. So here let us say 2 molecules of carboxylic acid is reacting with 2 atoms of metals. So they will form metal salt, that is RCOOM, plus H2 gas will be released out here. Okay, so this is the general reaction for our reaction of carboxylic acid with metals. So here we can take example. For example, we are taking 2 molecules of acetic acid which is reacting with 2 atoms of sodium. So there the formation of 2 molecules of sodium acetate will take place and hydrogen gas will be released out here. So this is sodium acetate. Sodium acetate. Okay. Similarly, if 2 molecules of acetic acid, that is ethanoic acid, okay, it is also called as ethanoic acid. The other name of acetic acid is ethanoic acid. When it is reacting with zinc, so we know that the zinc is having what? Zinc is having the valency of +2. So here 2 carboxylate ions, they will get attached with the zinc here, and the formation of zinc acetate will take place with the release of hydrogen gas. Okay. Similarly, if I am talking about the aromatic compounds, aromatic carboxylic acid, that is 2 molecules of benzoic acid I am taking. Benzoic acid, it is been reacted with 2 atoms of sodium. So they will form sodium benzoate. Okay, the formation of sodium benzoate will take place with the releasing of H2O gas. Okay, sodium benzoate. This is your benzoic acid. Benzoic acid. Next is the reaction number 2, that is reaction of carboxylic acid with alkalis. Reaction of carboxylic acid with alkalis. Okay, so here carboxylic acid neutralizes alkalis to form salt and water. So it is a very general reaction which is called as neutralization reaction, where an acid when will react with a base, so they will produce a salt. So here the salt, if I am taking an example of acetic acid which is reacting with sodium hydroxide, then the formation of sodium acetate and water will take place here. So it is a very obvious reaction which is called as neutralization reaction, which you are studying from your very previous classes. Next is the reaction of carboxylic acid with carbonates and hydrogen carbonates. That is CO3 and hydrogen carbonate or bicarbonates, that is HCO3. So here, when two molecules of acetic acid, if it is reacted with, let us say, an example we are taking here for sodium carbonate, then here the formation of 2CH3 COONA plus carbon dioxide and water will be taking place here, and the formation of here also sodium acetate, that is a salt, will take place here. Okay, why this happened? Because the acetic acid, it is acidic in nature, and the carbonates which are taken out here, they are having the basic nature here. So here also a type of neutralization reaction will occur out, and the formation of salt, that is sodium acetate, and carboxylic and carbon dioxide and water will take place here. Also we can take one example for the CH3COOH, that is acetic acid, which is reacted with sodium bicarbonate, then the formation of sodium acetate with release of carbon dioxide and water will take place. Okay, so here the reaction mechanism for the reaction of sodium with the sodium bicarbonate, here it is that when carboxylic acid is reacted with sodium bicarbonate, so there Na plus and CO double bond OH, where O is having the negative charge and Na is having the positive charge, so therefore they are forming a ionic compound here. Here this negative charge oxygen, it attacks the hydrogen of the acetic acid, and the bond here, it converts from OH bond to C double bond O bond. Okay, and due to this reason, the formation of C double bond O minus takes place, and here due to the breaking of this bond, Na plus, okay, Na plus which is present out here, it will get attached here to this oxygen atom which is now formed out here, and the formation of ONA will take place. Now here you can see that C double bond OH is there, and a formation of OH has taken place. So this OH will again attack the H plus ion which is present there in the this particular ion, where a single atom is been present out here. Okay, and the formation of, oh sorry, one second, this has been became wrong. I am rubbing this is here only. Here the attachment of the OH will take place here, and which is an unstable compound here. Okay, why unstable? Because two OH has been attached with the carbon atom here. So here the removal of water will take place, dehydration will take place here, and the formation of C double bond O, C double bond O will take place here. Okay, so it means CO2 plus H2O will be formed out here. So this is the this is the formation of carbon dioxide and water with the reaction of hydrogen carbonate with that of the carboxylic acid. Now next, where these were the reaction in which the cleavage of the OH, the H from the OH bond was taking place. Now next type of reactions here is that in which reactions involving the OH group of carboxylic acid. Okay, means here the bond breaking will take place between the COH. Okay, while in the previous case it was breaking between the O and H here. So here the first reaction in this particular type is the formation of acid chlorides, means the formation of the derivatives of the carboxylic acid, and in that the first is the formation of the acid chlorides. So when carboxylic acid are treated with phosphorus halides, that is PCl5 or PCl3, or thionyl chloride, this is SOCl2, in the presence of pyridine, they form the acid chlorides. So here when carboxylic acid is reacted with PCl5, then the formation of RCOCl plus POCl3 and HCl will take place here. Okay, so taking an example here, we can take an example that is acetic acid. It is been reacted with PCl5. So here CS3 COCl, that is acid and acetyl chloride. Okay, acetyl chloride, POCl3, phosphorus oxychloride, and HCl, hydrogen chloride, will take place here. The next is the reaction of carboxylic acid with PCl3, and here in the presence of pyridine this reaction is taking place. Okay, pyridine is there, here also pyridine is there. So then the product will be RCOCl plus H3PO3. Okay, so here 3 molecules will be required in order to form 3 molecules of acid, that is acid chlorides. Here you can take example for 3 molecules of CS3 COOH plus PCl3 in the presence of pyridine, 3 molecules of acetyl chloride with the phosphorus acid will taken place. Now if you are talking about the benzoic acid, okay, so benzoic acid can be reacted with PCl5 to form C6H5 COCl plus POCl3 plus HCl, or it can react with C6H5 COOH plus thionyl chloride, that is SOCl2, to form C6H5 COCl plus SO2 plus HCl here. Okay, so these were the reaction or the formation of acid chlorides. Next, formation of next next carboxylic acid derivative, that is esters. Okay, so here generally this reaction is also called as reaction with alcohols. Okay, the reaction of carboxylic acid with alcohol, and this process is called as esterification, because when carboxylic acid is reacted with alcohol, so before the indication of this reaction is that carboxylic acids are having a smell which is containing sourness in them. Okay, but after reaction of carboxylic acid with alcohols, a sweet smelling compound is formed, and this sweet smelling compound is nothing other than the esters. Okay, so here CS3 COOH plus HO C2H5 is taken. Okay, that is, we have taken ethanoic acid or acetic acid which is reacting with ethyl alcohol, that is ethanol. Ethyl alcohol, that is ethanol, in the presence of concentrated H2SO4. Okay, the reaction enhancer or the initiators will be HCl or H2SO4. Either of them can be used out here. So here the product will be formed out, that is ester CS3 COO C2H5 plus H2O. Okay, that is, the name of this compound is ethyl acetate, or you can name it as methyl ethanoate, ethyl methanoate. Okay, the name will be ethyl ethanoate. Okay, ethyl ethanoate. Next, C6H5, that is benzoic acid. When it is been reacted with alcohol, that is C2H5, then the formation of water will take place, and in the presence of H2SO4, the produced compound will be C6H5 COO C2H5, that is ethyl benzoate. Okay, so the reaction is shifted towards the right with excess of alcohol. If excess of alcohol is there, then the formation of ester will take place, and the removal of water can be done by distillation here. The reactivity here for the alcohols with that of the esterification here, it depends on the type of alcohol which is used out here. So here, if tertiary alcohol is used, so it will having the least reaction with that of the carboxylic acid to form the esters, while the secondary alcohols will be having more reactivity as comparison to that of the tertiary alcohols. The primary will have more reactivity as comparison to that of the secondary alcohols, and the methyl alcohol, it will be the most commonly reactive with that of the as comparison to that of the primary alcohols. Means the single carbon alcohol group, they will readily form the esters as comparison to that of the primary, as comparison to that of the secondary, and as comparison to that of the tertiary alcohols. Similarly, for the carboxylic acid also, the carboxylic acid where the alpha carbon, if it is having the tertiary compound, then it will be having the lowest chance of forming the esters as comparison to that of the secondary one, okay, as comparison to that of the here no H will be there, only C will be there, that is R3CCOOH. Here only one H will be there, and in here RCH2COOH as comparison to that of the acetic acid, and the formic acid will be the most reactive here, and it will easily form the ester here. What is the main reaction mechanism in the esterification? So here in the esterification, the carbonyl group of the carboxylic acid here, they attacks the H plus ion, okay, attacks the H plus ion of the oxygen of the carboxylic okay, here the oxygen of the carboxylic acid, it attacks the H plus ion, and which is been produced by the H2SO4 or HCl, which is used out there. So it will act as an initiator here, and the formation of O plus H and OH, that is protonated carboxylic acid, will take place here. Now this protonated carboxylic acid is unstable, and the rearrangement will take place here, and the bond will break out between the carbon and oxygen, and the formation of diol, means two hydroxyl group will be get attached to the carbonyl group, okay, it will convert into diol. Now as the protonation has been occurred out here, the carbonyl group gets activated, okay, here the carbon has been activated as the positive charge has been formed out here, hence it readily undergoes the attack by the lone pair of electrons of the oxygen of the alcohol group. So here the OH and OH, and here the positive, that is the carbocation, it will be get attacked from that of the oxygen of the alcohol group, okay, and due to this the formation of tetrahedral intermediate, that is RCOH OH, which is connected with O, okay, and here also the lone pair has been donated to carbon, so due to this reason the oxygen will obtain a positive charge here, and the formation of a tetrahedral intermediate or a adduct compound will take place here. Now from this intermediate compound a proton shift will occur, and the formation of water will take place here, okay. So here the formation of protonated compound will take place here due to this. So here the compound will convert into the form like this, where this O, it will get attached to the 2H here, and a positive charge will gain out here, and this O, it will get back its two lone pair of electrons. Now the intermediate obtained here, this water molecule which is attached to the carbon atom here, it will get detached out here, and the formation of and oxygen, okay, here also a lone pair of oxygen was there, so it will get back out here with the carbon atom, and the formation of C double bond OH with a positive charge on O, and OR dash, which has been attached out here with the carbon, it will take place here, okay. Now water has been removed out, here, okay. So now the rearrangement will take place here, okay, and after the rearrangement the protonated, it is called as protonated ester, the formation of protonated ester has been taken place here. Now after the rearrangement here of the protonated ester, what will happen after the rearrangement here, if I am going in details, so here the bond is like this between oxygen and hydrogen, so this bond will be shifted towards the oxygen, this lone pair of electrons will be shifted towards the oxygen, and the formation of RC double bond O with OR dash will take place, that is the ester. And here again H plus ion is been released, which will initiate the next molecule of the carboxylic acid. Okay, so hence with this only the reaction will take place here continuously. Okay, in the case of the while if you are considering in the case of the ketones, so this reaction converts into the what we can call into a reversible reaction. Okay, that is more reversible as comparison to that of your carboxylic acid. Okay, next, seventh is the formation of amides. Formation of amides. So carboxylic acids react with ammonia to form ammonium salts, which upon heating forms acid amides. Okay, so what happens? Okay, for general reaction I will use the red ink. So RCOOH plus ammonia, when carboxylic acid is reacted with ammonia, so in the reversible reaction formation of ammonium salt of carboxylic acid will take place, and further on heating of this ammonium salt, the production of amides and water will be taken out. So some example can be taken: CS3 COOH plus NH3. So a adduct compound, that is RCOO NH4 plus will take place. On heating, the removal of water will take place here and formation of amide, that is in the place of R I will use the CS3COO here, CH3CONH2, that is acid amide. Okay, that is acid amide take place here. Okay, in the benzoic acid also the same compound formation will take place, that is C6H5 benzoic acid. When it is reacted with ammonia, an adduct compound, that is ammonium salt of benzoic acid will take place, and on heating of this compound, the formation of benzamide and water will be found out here. So benzamide. Okay, next, if phthalic acid is taken out, okay, phthalic acid means C6H5 COOH twice. This is phthalic acid. If phthalic acid is reacted with ammonia, so here two molecules of ammonia will be required. Okay, in the case of phthalic acid, here two molecules will be required out for ammonia, and the formation of ammonium phthalate will take place, NH4 plus COO minus NH4 plus. This is ammonium phthalate. Further, on heating, the removal of two water molecules will take place, and here phthalamide will take place, formation of phthalamide COONH2. It will be COONH2 COONH2, and on strong heating, the ammonia will also be removed out here, and the formation of C double bond O NH, C double bond O NH, that is phthalimide will take place. Phthalimide will take place. Okay, so this is one of the important reaction. You can remember this reaction, that when phthalic acid is reacted with ammonia, so the formation of phthalimide is take place. But here two step reaction is there. In the first step, the formation of three step reaction is there. In the first step, ammonium phthalate is formed when two molecules of ammonia react with phthalic acid. On first heating, it will produce the phthalimide. Okay, but on the one more strong heating, it will produce phthalimide. Okay, phthalimide, while here it is phthalimide. PTHALAMIDE. This is phthalimide, and this is phthalimide. Okay, so this is one of the important reaction. Next is the formation of acid anhydrides. Formation of acid anhydrides. So the general reaction, RCOOH. Okay, carboxylic acid is heated with in the presence of strong dehydrating agents such as phosphorus pentaoxide or sulfuric acid to form corresponding acid anhydrides. Okay, so here two molecules of carboxylic acid, when heated in the presence of phosphorus pentaoxide or H2SO4, then here the removal of water will take place. So I will write this particular compound in the form like this, HOOCR. So here the removal of water will take place and the formation of RCOOCR, that is anhydride. Okay, acetic anhydride will take place here. Alkyl anhydride will take place here with the water. So here an example can be taken as two molecules of CS3 COOH is taken. So here the removal of water will take place, and the removal of water will take place on heating with these two molecules of carboxylic acid in the presence of phosphorus pentoxide. Then the compound will be formed out here, CS3CO, that is acetic anhydride. Acetic anhydride with the removal of water. Okay. The same reaction will be for the aromatic carboxylic acid. One more example for the aromatic compound here, C6H5 COOH with again benzoic acid. So here the removal of water will take place when heated with phosphorus pentoxide, formation of benzoic anhydride. Okay, plus water. Benzoic anhydride. Next, for today we are commencing the class. We are ending the class here only, and in the next class we will see some of the more reactions of the carboxylic acid, and then for last of this chapter, that is the distinction of the carboxylic acid. Okay, how we can distinguish between the phenols or aromatic acids and the aliphatic carboxylic acid. What is the way to distinguish them? it will be also discussed out here in our classes in the next class. So for today I am ending the class here only. We will meet in the next class. Thank you.